Okay, so this is the last video on Oxford MAT questions that I'm going to do for now. Let's change the colour of the ink again. This time we're going to go green. So this says, a line is tangent to the parabola y equals x squared at the point a squared, where a is larger than 0. The area of the region bounded by the parabola, the tangent line, and the x-axis equals, and then it gives us a bunch of options for what it equals. So first thing that I would want to do with this is visualize it. I want to know what I'm working with. So firstly, let's draw a big axis. We can get rid of this eventually, because we can use this quadrant because we know that a is larger than 0. So we want a, which is some number, to be positive. Let's change the color of our ink to maroon. So we want an x squared, which looks something like this, or whatever. It's a rough drawing, it's not meant to be perfect. And then we want to pick some point. Let's use blue. Can I pick blue? Yeah, I can. We want to pick our point a squared, so let's just say it's here. And we're trying to draw some tangent. Pretend that's a good line. It's not a good line, it's a terrible line, but pretend it's a straight line that is tangent. In fact, I'm going to have another go at that line. I don't like that line. Pointer options, eraser. Let's get rid of that. And then screen, nope, pointer options, ink color, blue. We're going to something like that. That's better. Okay, so we want the region bounded by. Now, the word bounded by is an area that could confuse you, because it can confuse me. It basically just means in between, or surrounded by. So we need to find an area which is surrounded by the parabola, which is our brown line, the tangent line, which is our blue line, and the x-axis, which is our green line. So we're looking for this area here. So what we want to do is that we want to work out our we want to work out the area underneath the parabola, and then we want to subtract the area underneath the tangent, but the line between the tangent and the x-axis, which is here. So we want to know we know what this point is here, because we know what this coordinate is. This coordinate is a squared. Our x coordinate is a. So we know that this is going to be between a, and where does this finish? It finishes at 0. So we know that it's going to be between a and 0. But then we want to subtract the area of our triangle. We need to work out the area of our triangle. We know the height of the triangle. It's a squared, because that is the difference in. This is the difference between a0 and a squared. That is how much we have translated to get from the point that touches the x-axis to the point which is tangent to our parabola. We now need to know this point here, and it will be helpful if we could actually work out the equation of our tangent in order to work out where it intercepts the x-axis. I'm going to change the colour of the pen again, just so we can differentiate between different things that we're doing. Let's go to red. So, in order to work out I'm just trying to look at what I did for this. Yeah, okay, so if we want to work out our gradient, any tangent is in the form, is the general equation of a tangent. It can be helpful to write y minus y1 equals mx minus x1. We have our y1 and our x1 because we have our coordinates here. We have y minus a squared equals mx minus a. But we don't know our gradient, and we need to work out our gradient. And our gradient is not difficult to work out. If you want to work out the gradient of any point on a line, you differentiate the equation of the line and then plug in the point you're looking for. So our line is y equals x squared. Differentiating our x squared gives us 2x. The point on our equation that we're on our parabola that we're looking for is when x equals a. So we plug in a, and we know that the gradient is going to be 2a. So we can substitute our m value with 2a, and we now have y minus a squared equals 2a x minus a. Let's expand this right hand side. 2a multiplied by x is 2ax. 2a multiplied by minus a is 2a squared. Let's add this positive a to both sides. So we now have the equation y equals 2ax minus a squared. But we want to know, what is the value of x when our tangent intercepts the x-axis? The x-axis always has a y value of 0. So we just substitute in 0. Where's the pen gone? There it is. So 0 equals 2ax minus a squared. We can divide both sides by a, since a is just a constant. We're then left with 2x minus a equals 0, x equals a over 2. So we now know that this point here is a over 2, 0, and those are the coordinates. What's the difference between a over 2 and a? Because you want to work out this line here, it's a over 2. So the area of our triangle is just the base times the height divided by 2, a over 2 multiplied by a squared, which is our height here, and then we want to halve it, base times height over 2, times by 1 over 2, which gives us a cubed over 4. A times a squared is a cubed, the half times our new half is a quarter, and that's what we've got. So we now know this area here, it is a cubed over 4. Now what is our area under the parabola? Now if we integrate x squared, we get a third x cubed. We substitute in a, we get a cubed over 3. We substitute in 0, we get nothing. So we now have our final equation, which is a cubed over 3 minus a cubed over 4. And this gives us, and let's change the colour of the ink just so the answer kind of screams out at us. Let's go black. Is a cubed over 12. And that is the answer. That was a bit of a longer question, a bit more work involved, but we got there in the end. This question will be one that will take a little bit longer than the rest. It kind of combines a bunch of different things that you'll have learned in order to kind of answer this question. It looks a bit. I reckon this will come with the kind of question that on a A-level exam might be worth, I don't know, 4, 5, 6 marks. It's one of the more difficult questions. It's one of those questions that when you come out of the exam hall, you're chatting to each other and you're thinking, oh, did you see that question E? Oh, I hated it. It was horrible. How'd you do that? And you just combine like a million different things, and it's a bit unfair to have to ask you to do that, especially in exam conditions, but there you go. People that write maths exams are evil. Anyway, that's the final Oxford MIT video I'm going to do for now. Thank you for watching, and I hope you found this helpful.